Hi, Shalom. My name is Samuel Olawi, and with me here is.
We love Neshedo.
And together we are from Baptist High School, just representing the BMS Junior category. Today we are excited to present to you SecureVOTE, a mobile application we built entirely using MIT App Inventor. SecureVOTE is designed to make elections in Nigeria safer, faster, and more transparent. Let us start with why this app is needed. Every Nigerian has seen what happens during election: rigging, voter intimidation, ballot snatching, destruction of property, and results that no one trusts. Using the most recent elections as our case study, our app directly tackles 6 major problems. First, rigging and manipulation of ballot papers. Second, voter insecurity and thuggery at polling units. Third, the enormous cost of running elections. Fourth, the inconvenience of long queues and traveling for voters. Fifth, the destruction of public and private property. And sixth, the excessive time it takes to count and announce results. SecureVOTE addresses every single one of these problems.
To build SecureVOTE, we used the iterative and incremental development model. This model was perfect for our project because it allowed us to build, test, improve the app in small stages or sprints, rather than trying to build everything at once. As you can see, we divided our work into 5 sprints: plan, design, build, test, and deploy. We are currently in sprint 3, the build phase, where core voting interface is complete and we are integrating Firebase for the live database. Sprint 4 and 5 will complete PVC scanning, facial recognition, and live analytics. This is our system activity diagram. It shows us exactly what happens when a voter uses SecureVOTE step by step. First, the voter opens the app and logs in with their phone number. Then they scan their permanent voter's card, their PVC, using the phone's camera. The app then takes facial recognition photo and compares it to the PVC image. Here is our key security check. If the face matches, the voter proceeds. If it doesn't match, they are asked to try again. This is what prevents fraud. Once verified, the voter selects the election and casts their single vote, which is saved instantly to our Firebase database, and our live analytics screen updates in real time.
Here are 6 core system requirements we identified before building. The most critical ones are the MIT App Inventor as our development platform, Firebase as our real-time database, and the barcode scanner for facial recognition, API for identity verification. All of these components work together to make the app both secure and user-friendly. Now, let us look at the app user interface, what the voter actually sees. We designed 5 major screens. The authentication screen is where the voter enters their phone number and OPT to prove they are registered voters. The election screen lets them choose between the presidential, gubernatorial, or local elections. The manifesto screen shows the candidate's profile and party information so voters can be informed of their choice. The ballot screen is the actual voting page, clean, simple, and secured. Once you vote, the button is disabled so you cannot vote twice. And finally, the analytics screen, which shows live results as votes come in.
On the left, you can see the structure of our Firebase real-time database. We have 2 main data trees: election, which stores votes counts per candidate, and voters, which stores whether each voter has already casted their vote. On the right are the 3 most important logic blocks in our app. The first shows new votes incrementing the candidate's count in Firebase. The second checks if the voter has already casted their votes. If they have, we show an error and block the ballots. This is how we prevent duplicate voting. And the third is our live dashboard, Firebase data change. Even events fire automatically whenever new votes come in, and the screen updates instantly. No refresh needed.
This slide shows 4 major features we implemented in App Inventor's block editor. We use the barcode scanner component. When the voter taps Scan PVC, it activates the camera, reads the barcode, and returns to the voter ID number. That ID is then used to look up the voter's record in the Firebase. The camera component captures a photo, which is sent via a web component to face recognition API. The API returns to a match score. If it's above our threshold, the voter is granted access. Before any voter is recorded, we check the hasVoted flag in the Firebase. If it's true, the ballot is locked. If false, the vote goes through and the flag is sent through permanently. We use store value and get value for writing and reading data, and data change for all our real-time updates on the analytics screen. Here is a summary of every tool and platform we use to build SecureVOTE. MIT App Inventor for everything you see on the screen, all the UI and the code blocks. Firebase for our real-time database and live voting counting, the barcode scanner component and facial recognition API for identity verification, Omelette to draw our activity diagram, logo.com to design our app icon, and of course Canva and Microsoft PowerPoint for this presentation. We are proud that every tool we used is accessible. Most of them are completely free.
SecureVOTE is not finished, and that is intentional. We are building it in sprints, and here's what comes next. Sprint 4 will connect us to the INEC database for real vote registration verification. Sprint 5 will complete the full PVC barcode scanning pipeline, integrating it with live photo data from INEC. Sprint 6 will finalize the facial recognition API, ensuring that every voter's identity is confirmed biometrically before they can access the ballot. And Sprint 7 will build our full-time analytics dashboard with real-time charts, state-by-state breakdowns, and results projections. Our vision is in Nigeria, where every vote counts and every voter is verified. In conclusion, SecureVOTE proves that young Nigerian students using accessible tools like MIT App Inventor can build technology that solves real national problems. We have built an app that eliminates rigging through biometric verification, prevents duplicate voting through Firebase flags, and delivers live election results to every Nigerian's phone. We believe that free, fair, and transparent elections start with technology that is secure, simple, and built by Nigerians for Nigeria. In our next sprint, SecureVOTE will be complete, deployable voting system. Thank you very much. We are Mulabne Sherdun
And Samuel Olawi
from Baptist High School Jos, and we are happy to take your questions or show you the app live.